Welcome to this lecture on Git basics and branch management. In this session, we're going to walk through the core concepts of Git, what a repository is, how to track changes, what head means, how branches work, and how to manage them effectively. Whether you're just getting started or looking to solidify your understanding, this is going to give you a strong foundation. Let's dive in. Let's start with the very basics. What is a repository or repo? A repository is simply a folder, just like a folder or directory on your Windows or Linux system. The difference is that on GitHub, this folder has a special name. It's called a repository, or repo for short. So when someone says create a repo on GitHub, they just mean create a folder that Git is tracking. And how do you create one locally? You use the command git init. That command initializes a new Git repository in your current folder. Before we go deeper, let's do a quick review of the core Git commands that form the foundation of everything we do. First, git init creates a new repository. Then git add, with a dot to add everything, or with a specific file name, stages your changes, meaning you're telling Git which files you want to include in your next save. Git status shows you what's going on right now, which files are modified, staged, or untracked. Git commit -m followed by a message is how you actually save a snapshot of your work, and the -m flag stands for message. Then git log shows you the full history of commits, and git ref log shows you an even more detailed log of every reference change, including resets and branch switches. These are your everyday tools in Git. Now, let's talk about one of the most important terms in Git, head. This is a term you'll see constantly, and it's crucial to understand what it means. Head is a pointer. That's it. It's just a pointer. It tells Git two things: which branch you are currently on, and which is the most recent commit in that branch. So right now, if you're on the master branch, head is pointing to master, which in turn points to the latest commit you made. Think of head as Git's way of saying you are here. When you did a soft reset earlier, undoing the latest commit, what you were really doing was moving head back one step. So head always reflects your current position in the Git history. Let's make this concrete with an example. Imagine you're on the master branch. Head is pointing to master, and master is pointing to your latest commit. Let's call it C3. Now you create a new branch called service and switch to it. At this moment, head moves. It now points to the service branch, which still has the same commits as master up to C3. Then you make a new commit on the service branch. Call it C4. Now head points to service, which points to C4. If you switch back to master, head moves back to master and C3. This is how Git always knows where you are and what your latest work looks like. Now let's talk about merging. The simplest type of merge is called a fast-forward merge. Here's the scenario. You're on master, you create a new branch, say service, and you do some work there, making a new commit. Meanwhile, nobody touches the master branch at all. When you come back and merge the service branch into master, Git doesn't need to do any complex combining. It simply moves the master pointer forward to point at the new commit on the service branch. That's it. It just fast forwards. No conflicts, no complicated resolution. This is the ideal scenario, and it happens a lot when you're working alone, or when your team is disciplined about not modifying the main branch while you work. Now let's look at the more realistic scenario, the three-way merge. This happens when both branches have new commits after the point where they diverged. Imagine you branched off from master at commit C3 to create a service branch. You made commit C4 on service, but at the same time, someone else, or you yourself, made a new commit C5 on master. Now when you try to merge, Git can't just fast forward because master has moved on. Instead, Git looks at three things: the common ancestor, C3, where both branches started, the tip of the master branch, C5, and the tip of the service branch, C4. It combines all three to create a brand new merge commit, C6. This is called a three-way merge, and it's what you'll encounter most often when working in a team. Let's walk through the practical workflow of creating and working on a new branch. Say your team asks you to build a service page. The first thing you do is create a new branch for that work. The shortcut command is git switch -c followed by the branch name. Here, service page. The -c flag stands for create, so this creates the branch and switches you to it in a single step. You could also do it in two steps with git branch and then git switch, but the combined command is faster. Once you're on the new branch, run git branch to confirm. You'll see all your branches listed, and the one you're currently on will have an asterisk next to it. Then you do your work, stage the files with git add, commit with git commit -m, and when you're done, switch back to master with git switch master. Let's ground this in a real example from the material. Imagine your master branch has a website with a navigation bar containing 4 menu items, a hero section, and an about page with a description and an image. Your team lead now asks you to add a service page, so you create a new branch called service page from master. At the moment of branching, your new branch is an exact copy of master. It has everything master has. You then create a new file called service.html, add an h1 heading that says service page, write some description content, and commit it. Now, here's the key thing to understand. If you switch back to master and look at your files, service.html is gone. It doesn't exist on master. It only lives on the service branch. This isolation is exactly why branches are so powerful. Your work in progress doesn't affect the stable main codebase. Once you've merged a branch and its work is safely in master, you'll want to clean up by deleting the branch. You do this with git branch-d followed by the branch name. The lowercase -d is a safe delete. Git will warn you if the branch hasn't been fully merged yet, protecting you from accidentally losing work. After deleting, run git branch again to confirm it's gone. One important thing to note, you cannot delete 2 branches at the same time in a single command. You might think you can separate them with a space, but be careful. Always delete branches one at a time to avoid mistakes. Accidentally deleting a branch that has unmerged work can cause you to lose those changes, so take it one step at a time. Sometimes you'll want to rename a branch. For example, many projects are moving away from calling the main branch master and renaming it to main. Or maybe you want to call it stable to indicate it's the production-ready version. You can do this easily with git branch-m, where -m stands for move or modify. It's the rename flag. So git branch-m master main renames master to main. And if you later want to rename main to stable, you'd run git branch-m main stable. It's that straightforward. This is a non-destructive operation. You're just changing the label, not the commits or the history inside the branch. Let's put together a quick reference of all the branch management commands we've covered. Git branch lists all your branches. Git switch-c with a name creates and switches to a new branch in one step. Git switch with just a name switches to an existing branch. Git merge merges another branch into whichever branch you're currently on. Git branch-d safely deletes a branch. And git branch-m with the old and new names renames a branch. One golden rule to always keep in mind, before you merge or delete, double-check which branch you're currently on. Running git branch or git status first is always a good habit. It saves you from merging into the wrong branch or deleting something you didn't intend to. Let's pick up right where we left off with a quick recap of the core Git commands we've been working through. We have git status, which tells you the current state of your files. Git commit with the -m flag lets you save a snapshot with a message. Git log shows your commit history, and git reflog goes even further. It shows absolutely everything, including resets and checkouts that wouldn't normally appear in a regular log. If you want a compact view, git log-online puts each commit on a single line. Git revert is your safe undo button, and git config-ust shows your current configuration, like your name and email. These are the foundational building blocks, so make sure you're comfortable with all of them. A student asked a really important question. What's the difference between git revert and git reset? Both of them are ways to undo changes. That much is true. But the key difference is in how they undo. Git revert creates a brand new commit that reverses the changes from a previous commit. Your history stays intact. You can always see what happened. Git reset, on the other hand, actually moves your branch pointer backward, which can effectively erase commits from your history. This makes reset more powerful, but also more dangerous, especially if you're working on a shared branch that others are also using. So think of revert as the safe, non-destructive undo, and reset as the more aggressive one. Now let's talk about the three-way merge. This is a concept that comes up when 2 branches have diverged from a common point. Here's how it works. Imagine you have a master or stable branch, and at some point someone created a feature branch, say a service page branch, from that same commit. Both branches then moved forward independently. When you want to bring them back together, Git can't just fast forward one onto the other because they've both changed. So instead, Git looks at 3 things: the common ancestor commit where they split, the tip of branch A, and the tip of branch B. Using all 3, it creates a brand new merge commit that combines the work from both sides. That's why it's called a 3-way merge. Here's something really practical about how teams use Git branch names to represent software version stages. The instructor walks through 3 common version labels. First, alpha. This is the version that only developers use internally for testing. It's rough, it's early, and it's not meant for the public. Then there's beta. This gets released to a limited audience, maybe early users or testers. Changes can still happen at this stage. And finally, stable. This is your production version. It's been tested, it's solid, and it's what real users interact with. The beautiful thing about Git is that you can name your branches anything you want. So you could literally have a branch called stable, one called beta, and one called alpha, and manage your releases that way. So how does this actually work in practice? The instructor demonstrates creating these version branches right in the terminal. You start on your main branch, and if you want a stable production version, you create a branch called stable using git switch-c stable. Then you can create a beta branch from that same point. The workflow goes like this. You push new changes to beta, let your audience test it, collect feedback, make fixes, and once everything looks good, you merge beta into stable and deploy that to production. This is a clean, real-world workflow that many development teams actually use. The branch name itself carries meaning. It tells everyone on the team what stage that code is at. Now, here's a really useful command, git diff. The instructor uses a great analogy here. Think of your files as passengers at an airport. The working directory is the airport itself, the staging area is the waiting room, and the repository is the plane. Once you're on, you're committed. So git diff shows you the changes that are sitting out in the airport, in your working directory, that haven't made it to the waiting room yet. You'll see lines in green with a plus sign, meaning those lines were added. Red lines with a minus sign would mean something was removed. This is incredibly useful when you come back after a break and can't remember what you changed. This is a subtle but important distinction. If your file is still in the working directory, not yet staged, then git diff will show you the changes. But here's the catch. Once you run git add and move the file into the staging area, git diff by itself shows you nothing. The file has moved to the waiting room, so it's no longer in the airport. To see what's in the staging area, you need to add the -staged flag, git diff -staged. The instructor's advice is great here. Always run git status first. If it says changes to be committed, your file is staged, so use git diff -staged. If it says changes not staged for commit, just use git diff. Knowing where your file is tells you which command to use. Git diff isn't just for comparing your working directory to staging. You can also use it to compare two branches directly. The instructor demonstrates this by comparing a stable branch and a comedy branch. The syntax is simply git diff followed by the two branch names. In the output, red lines with a minus sign mean that content exists in the first branch but not the second. Green lines with a plus sign mean the second branch has something the first doesn't. In the example, the comedy branch had an extra line added, shown in green, while the stable branch didn't have it, shown in red. This is a powerful way to review what's different between any two branches before you decide to merge them. Now, here's a scenario that every developer faces at some point, and it's really important to understand. The instructor sets up this situation. You're working on a feature branch, let's call it the story branch, and you're writing some content, say the Twinkle Twinkle Little Star rhyme. You've written half of it. Your work is not done, and you haven't committed yet, because a commit should represent a complete unit of work. Then suddenly, your manager calls. There's an emergency bug on the stable branch that needs to be fixed right now. You need to switch branches immediately. But here's the problem. You have uncommitted changes sitting in your working directory. What do? You can't just leave them, and you shouldn't commit half-finished work. This is exactly the problem that git stash was designed to solve, and that's what we'll be looking at next. Before we move on, there was a great question about the difference between revert, restore, and reset. So let's clear that up. Revert and reset are both essentially ways to undo changes. You're going backward to a previous state of your code. Restore, on the other hand, is more like a redo. It brings something back, similar to hitting Ctrl-Y in a text editor. Now, in practice, restore isn't used as frequently as revert or reset. The important takeaway is that all three deal with undoing or redoing work in Git. And here's something worth noting. If you're using VS Code, all of these operations are available through the graphical interface, so you don't have to memorize every command. But understanding what's happening under the hood is crucial when you're working professionally. Now let's talk about one of the most important concepts in Git collaboration, the three-way merge. Here's the scenario. Imagine you started with the master branch, and you created a new branch called service page. You copied the exact state of master at that point, so your service page branch has an index.html file with just a hero section. Now, while you were working on your service page branch, someone else came along and made changes to the master branch. They added a brand new section, a message from principal section, and committed it. So now master has changed since you branched off from it. Your service page branch does not have that new section. Two different versions of the same file now exist across two branches. This is the classic three-way merge scenario. So here's where it gets interesting. On the master branch, someone renamed the hero section and also added a message from principal section. On the service page branch, you renamed the hero section to something else, like hero section notice. Now, both branches have modified the same file, but in different ways. When you try to run git merge service page from the master branch, Git can't automatically decide which version is correct. It sees two conflicting changes to the same line or section. This is what triggers a merge conflict, and this is actually the most common problem you will face when working in a team. It's not something to be scared of. It's just Git asking you, hey, two people changed the same thing. Which one should I keep?
When a merge conflict happens, VS Code makes it really easy to resolve. You'll see the conflicting code highlighted with markers. The section labeled head, or current change, shows what's in the branch you're currently on, which in this case is master. The section labeled incoming change shows what's coming in from the branch you're merging. Above the conflict, VS Code gives you 4 clickable options. Accept current change keeps your version, the head version. Accept incoming change keeps the other branch's version. Accept both changes keeps both pieces of code together. And compare changes lets you see a side-by-side diff. So in a real team setting, 2 developers would discuss which version is better, which one should we keep, and then one of these options gets chosen. It's a conversation, not just a technical step. Once you've chosen which version of the code to keep, you're not done yet. You need to tell Git that the conflict has been resolved. Here's the process. First, save the file after making your choice. Then stage the file using git add dot. Finally, commit the resolution using git commit with a message. This commit is what officially closes the merge conflict and completes the merge. Git needs that final commit as confirmation that you've reviewed the conflict and made a decision. Without it, the merge stays in an unfinished state. This is a critical step that beginners often forget. Always commit after resolving a conflict. Now, let's talk about a scenario that every developer faces at some point, the emergency fix problem. Here's the situation. You're working on a feature branch called Story. You've written some code, maybe half of a feature, but it's not done yet. And remember the rule, you only commit when a task is fully complete, so you can't commit yet. Then suddenly, your boss calls. There's a critical bug in the stable production version, and you need to fix it right now. So you need to switch to the stable branch immediately. But here's the problem. If you switch branches without committing, your incomplete work either follows you to the other branch or gets lost. You can't just copy-paste it somewhere and come back. That's messy and error-prone. So what do? The solution is a Git command called git stash. Think of stash as a temporary safe or filing cabinet. When you run git stash push with a message, Git takes all your uncommitted in-progress work and stores it in a hidden temporary location. Your working directory becomes completely clean, as if you never made those changes. The key thing here is that this is not a commit. It's not tracked in your branch history. It's just a temporary holding area. Once you stash your work, you can freely switch to any other branch without worrying about your incomplete code. The message you provide, like working on Story, helps you remember what you were doing when you come back. Let's walk through the complete stash workflow step by step. First, while you're on the Story branch with incomplete work, you run git stash push with a descriptive message. Your code disappears from the working directory, safely stored. Second, you switch to the stable branch using git switch stable. The stable branch is completely clean. Your Story code is nowhere to be seen. Third, you fix the bug on the stable branch, add the changes, and commit with a message like bug fix. Fourth, once the emergency is handled, you switch back to the Story branch using git switch story. And fifth, this is the magic step. You run git stash pop. This retrieves your stashed work and puts it right back where you left it, exactly as it was. You can now continue working on your feature as if nothing happened. The command git stash pop is what brings your work back. Think of it like a stack. You pushed your work onto the stash, and now you pop it back off. After running git stash pop, your incomplete code reappears in the working directory, exactly as you left it. The stash entry is also removed once it's popped, since you've retrieved it. There's also a useful command called git stash list, which shows you all the items currently in your stash, helpful if you've stashed multiple things. The mental model here is simple. Stash is like a clipboard for your entire working state. You can temporarily set everything aside, handle an emergency, and come back to exactly where you were. Now, here's an interesting follow-up scenario. After you fixed the bug on stable and completed your feature on Story, you want to merge Story back into stable. But when you run git merge Story, a conflict appears. Why? Because while you were away fixing the bug, you made a change to the stable branch. You added the bug fix code. And your Story branch also has changes to the same file, the new feature code. So now there's a conflict between the two.
In this case, the resolution is clear. You need both changes. The bug fix needs to stay, and the new feature needs to come in too. So you choose Accept Both Changes. This is a perfect example of why understanding what head means and which branch you're on is so important when resolving conflicts.
One thing that's easy to overlook but really matters in professional work is how you name your branches. When you look at a list of branches weeks or months later, the name should immediately tell you what that branch was for. A name like Branch 1 or Test tells you absolutely nothing, but a name like Login Bug Fix immediately tells you, oh, this branch was created to fix a bug in the login system. Or Registration Feature tells you this was where the registration module was being built. The rule is simple. Name your branch after the task you're working on. When you create a branch with git switch-c, give it a meaningful name right away. This is standard practice in every professional development team.
Here's something that surprises a lot of beginners. You don't always have to create a new branch from the main or stable branch. You can branch from any branch. For example, imagine you're working on a login feature branch. Within that login feature, you realize you also need to build a registration system. You can create a registration branch directly from the login branch. Then when registration is done, you merge it back into the login branch. And when the entire login feature, including registration, is complete and reviewed, you merge the whole thing into stable. This creates a tree-like structure of branches, and it's completely normal and encouraged. The key principle is branch from wherever makes logical sense for the work you're doing. Before you merge two branches, it's a really good habit to check what's actually different between them. That's what git diff does. The command git diff, followed by two branch names, shows you a comparison of the two. Lines marked with a plus sign are additions, things that exist in the second branch but not the first. Lines with a minus sign are deletions. Lines with no prefix are unchanged. This is incredibly useful because it lets you preview what's coming in before you actually merge. You can spot potential conflicts early, understand what your teammate changed, and make sure nothing unexpected is about to land in your codebase. Think of it as a pre-merge inspection. The last important concept introduced here is rebase. Let's understand what it does. Imagine you branched off from stable at a certain point. Let's call it commit B. You've been working on your test branch and made a couple of commits. Meanwhile, a teammate made a new commit on the stable branch, commit C. So now stable has moved forward since you branched off. Your test branch is based on an older version of stable. This is where rebase comes in. Rebase essentially replays your commits on top of the latest version of the base branch. Instead of your branch starting from the old commit B, after a rebase, it looks like your branch started from the new commit C. Your work is the same, but it's now built on top of the most current version of stable. This keeps the history cleaner and reduces the chance of conflicts when you eventually merge. So when do you use merge versus rebase? Here's a practical way to think about it. Merge is great when you're combining a finished feature into the main branch. It preserves the full history of what happened, every commit, every branch point. Rebase is better when you want to keep your feature branch up to date with the latest changes from stable while you're still working. It gives you a cleaner, linear history without extra merge commits cluttering things up. However, there's an important rule. Never rebase a branch that other people are also working on. Rebase rewrites commit history, and if someone else has based their work on those commits, it causes serious problems. Rebase is safe on your own private feature branches. Merge is the safe choice for shared branches. Let's bring together everything covered in this session. We explored the three-way merge, what happens when both branches have changed since they split, and how VS Code helps you resolve conflicts by choosing between the current change, the incoming change, or both. We learned that after resolving a conflict, you must always stage and commit to finalize the merge. We covered Git Stash, a powerful tool for temporarily saving incomplete work so you can switch branches for an emergency fix, then come back and restore your work exactly where you left it. We talked about meaningful branch naming. Always name your branch after the task. We saw that you can branch from any branch, not just main. We introduced git diff for comparing branches before merging. And finally, we touched on rebase as a way to keep your feature branch built on top of the latest version of the base branch. These are the core skills you'll use every single day in a professional development environment. So continuing from where we left off, now we're getting into one of the most important topics in Git, branching. And the reason branching exists is fundamentally about teamwork. When you're working at a company, you're never coding alone. There's a whole team, and everyone is writing code at the same time. If one person's code accidentally overwrites or conflicts with another person's code, things break. The codebase can get completely messed up. So how do you handle that? That's exactly what Git branching solves.
Here's a really intuitive way to think about Git. Think of it like a video game. Everyone has played something like Candy Crush, right? You start at level 1, progress through levels 2, 3, 4, 5, all the way to level 10. Now, if you get bored or want to replace something, you can go back to level 5 and play from there again. Git works exactly the same way. Every commit you make is like a checkpoint in the game. You can go back to any previous version, look at what the code looked like at that point, and even create a new branch, a new direction from that point. That's the power of Git.
When you open Git-related tools, you'll often see diagrams that look like dots connected by lines, sometimes branching off in different directions. These are Git branch graphs. Each dot is a commit, a saved checkpoint. The main horizontal line is your primary branch, often called main or master. When someone creates a new branch, you see a line diverging off from one of those dots. That branch can have its own commits, and eventually it merges back into the main line. To actually see this visually in VS Code, you can install an extension called Git Graph. Just go to the Extensions panel in VS Code, search for Git Graph, and install it. It gives you a beautiful visual of your entire commit and branch history. To make all of this concrete, let's walk through a super simple example. Imagine 3 friends who need to write a story together. Think of the story content as code, just to keep things simple. First, we create a new project folder and run git init to initialize a Git repository. Without this, Git has no idea what's going on in your folder. Then, one person creates a file called page1.txt and writes something simple, Johnny, Johnny, yes, Papa. They then run git add dot to stage the file and git commit with a message like add initial commit. That's the very first checkpoint on the master branch. Everything starts here.
Now, a second friend comes along and wants to add their part of the story, the climax section. Instead of writing directly on the master branch and risking conflicts, they create a new branch. The command is git switch-c climax. Let's break that down. Switch means you're switching to a branch. The -c flag stands for create, so you're creating and switching to a new branch in one step. And climax is just the name they chose for this branch. Once this command runs, you're now on the climax branch. Any changes you make here are completely isolated from the master branch. The master branch stays clean and untouched.
While on the climax branch, the second friend adds their content to the story. Maybe they write the climax section. They save the file, run git add dot, and then git commit with a message describing what they added. Here's the key thing to understand. These changes exist only on the climax branch. If you switch back to the master branch, you won't see those changes. The master branch still has only the original content. This isolation is exactly what makes branching so powerful. Multiple people can work on different parts of the project simultaneously without stepping on each other's toes.
Now let's talk about one of the more advanced but very important Git concepts, rebasing. Here's the scenario. You created a branch from a certain point on the master branch. Let's call that your base point. While you were working on your branch, someone else made new commits to the master branch. Now your branch is behind. It's based on an older version of the code. Rebasing means you're saying, hey, instead of being based on that old point, I want to rebase my branch on this newer, more up-to-date point. You're essentially replanting your branch onto a newer foundation. This keeps your branch current with the latest stable version of the code.
Here's how you actually run a rebase. First, make sure you're on the branch you want to rebase. In this example, the text branch. You can use git switch text branch to get there. Then you run git rebase stable, where stable is the name of the branch that has the newer commits you want to base yourself on. What Git does is take all the commits you made on your branch and replay them on top of the latest commit from the stable branch. It's like Git is saying, pretend you started your work from this newer point, not the old one. After this runs successfully, your branch now includes all the updates from stable, plus your own work on top. When you rebase, Git might run into conflicts, situations where both branches change the same part of a file in different ways. When that happens, Git pauses and shows you the conflict right inside the file, using those angle bracket markers. The section between the arrows labeled head is what's in your current branch. The section below the equal signs is what's coming in from the other branch. You need to decide, do you want to keep your version, keep their version, or keep both? In VS Code, you'll see helpful buttons like Accept Current Change or Accept Incoming Change right above the conflict. Once you've resolved it, you run git add dot and then git commit to finalize the rebase. The instructor in this example chose to accept the current branch's version since it already had everything needed.
Once you've completed the rebase and resolved any conflicts, you can now merge your branch back into the stable branch cleanly. Switch back to the stable branch with git switch stable, and then run git merge, followed by your branch name. Because you already rebased, meaning your branch's history is now aligned with stable's latest state, this merge will be clean and straightforward, often a simple fast-forward merge with no conflicts. This is the whole point of rebasing before merging. It keeps your project history linear and clean, rather than having a messy tangle of diverging and converging lines. You'll frequently see the word head in Git, especially during conflicts. Head simply means your current position. It points to the latest commit on whatever branch you're currently on. So when you see a conflict marker that says head, it's referring to your branch's version of the code. If you choose accept current change or accept head, you're keeping what you already have on your branch. Understanding head is crucial because it tells you exactly where you are in the Git history at any given moment. A student asked a great question here. During the rebase process, the branch names seem to change automatically to something like a hash code. This is completely normal behavior. When Git is replaying your commits during a rebase, it temporarily uses internal hash references. Once the rebase finishes successfully, your branch name comes back as expected. Also worth noting, if you ever want to rename or edit a commit message after the fact, you can use git commit with the -- amend flag. This lets you modify the most recent commits message without creating a new commit. So don't panic if you see a weird hash during rebase, it's just Git doing its internal work. Let's pull the whole workflow together. You start by initializing a repo with git init. You make your first commit on master. When a new feature or section needs to be worked on, you create a new branch with git switch -c and a branch name. You do your work, add and commit on that branch. If the main stable branch has moved ahead while you were working, you run git rebase stable to bring your branch up to date. You resolve any conflicts, finalize with git add and git commit, then switch back to stable and merge your branch in. That's the complete cycle. This workflow is how professional development teams keep code organized and conflict-free, even when dozens of people are working simultaneously. Before wrapping up this section, there is an important action item for everyone. For the next session, everyone needs to go to github.com and create a free account if you don't already have one. GitHub is where your Git repositories live online. It's the remote hosting platform that lets you share code with teammates, contribute to open source projects, and showcase your work to potential employers. Just go to github.com, click sign up, fill in the form, and verify your email. That's all it takes. The instructor also mentioned that detailed notes covering everything from today, branching, merging, rebasing, will be shared. So make sure to go through them step by step and try everything yourself. If you can do all of this comfortably, you'll be able to work with Git in any professional environment. Picking up from where we left off, the instructor asks students to open their project from the previous session and head into the extensions panel in VS Code. Once there, they need to search for an extension called Git Graph and install it. The instructor points out that the correct one to install is the version with over 2 million downloads. That's the popular, well-maintained one that appears at the top of the search results. So open VS Code, go to Extensions, type Git Graph, and hit Install. Once Git Graph is installed, students will see a visual panel that shows their entire commit history as a graph. The instructor explains this using a simple diagram, a vertical line with dots on it. Each dot represents one commit. The first dot at the bottom is the very first commit. The second dot is the second commit. The third dot is the third commit, and so on. So Git Graph is essentially turning your invisible commit history into something you can actually see and understand at a glance. Every time you made a commit, it recorded a snapshot, and now you can see all of those snapshots laid out in order. Now, here's where things get really interesting. In the Git Graph, you might notice that at some point, the single line doesn't just continue straight, it splits. A new line shoots off from one of the dots. That, the instructor explains, is called branching. Think of it exactly like a tree. A tree has a main trunk, and at some point, a new branch grows out from it. In Git, the same thing happens. Your project has a main line of commits, and at any point, you can create a new branch that grows separately from that main line. The original line keeps going, and the new branch develops on its own. This is the core idea behind Git branching. So why do we even need branches? The instructor sets up a scenario. Imagine you're working on a project. Everything is going fine on your main branch, but now you want to try something new, maybe a new feature, or you want to experiment with a different approach. If you do all of that directly on the main branch and something goes wrong, you've broken your entire project. Branches solve this problem. You create a new branch, do your experimental work there, and your main branch stays completely untouched and stable. If the experiment works out, you can merge it back in. If it doesn't, you just throw the branch away.
It's a safety net for your project. To make branching concrete, the instructor uses a fun example, a story project. The story already has some content, and now the instructor wants to write the climax section. Instead of writing it directly on the main branch, a new branch is created and named Climax. On this Climax branch, the instructor adds the climax content to the story file, something like Johnny Johnny, yes papa, eating sugar, no papa, and then stages and commits those changes. The commit message used is climax added, so the branch name describes what work is being done on it, which is a great habit to build. After creating the climax branch and making a commit on it, the instructor points out something important. Now the repository has two branches. You can see this in Git graph. There's the master branch, which is the original main line of the project, and there's the new climax branch, which has the climax content committed to it. These two branches exist independently of each other. The master branch does not have the climax content, and the climax branch has it. This separation is exactly what makes branching so powerful.
Here's where the magic really shows. The instructor demonstrates using the command getSwitch to move between branches. When you switch to the master branch, you open the story file, and the climax content is simply not there. It's gone. But then when you switch to the climax branch, you open the exact same file, and the climax content is right there. The file on your computer is literally changing its content based on which branch you're on. This is one of the most mind-bending things about Git for beginners. The same folder, the same file, but different content depending on your active branch. That's the power of isolated branch environments. The instructor wraps up by reflecting on how much ground has been covered across yesterday's and today's sessions. Between the 2 days, students have learned how to initialize a repository, stage and commit changes, view history, install Git graph to visualize commits, understand what commits actually mean as snapshots in time, and now create and switch between branches. The instructor says it directly. With all of this, you can work with Git like a professional. These are the foundational tools that real developers use every single day.
Before the next session, every student has one piece of homework. Create a GitHub account if they don't already have one. The instructor keeps it simple. Go to github.com, find the sign-up form, and fill it in. It's just like creating a Facebook account, straightforward and free. The reason this matters is that tomorrow's session will be all about GitHub, which is the online platform where you can store and share your Git repositories. So having an account ready is essential. Get that done before the next class, and you'll be all set to dive into remote repositories.
So let's pick up right where we left off and talk about why branches exist in the first place. The instructor uses a really relatable example here. Imagine you're building a school website. You've got your main project going, your master branch, and everything is working fine. Now suddenly you get an idea. What if I add this new feature or build a new version of the site? You don't want to just start hacking away at your working project, because if something goes wrong, your entire project is messed up. That's the core problem branches solve. The way to think about a branch is this. It's like making a copy of your project at a specific point in time, and then working on that copy. The instructor explains it clearly. You leave the original project exactly as it is, you take a copy of it into a new branch, and you do all your experimental work there. If your new feature gets completely messed up, your main project is completely safe. Nothing is broken. You just throw away the bad branch and start fresh. That safety net is exactly why branches are so powerful. So when exactly should you create a branch? The instructor gives us 3 clear scenarios. First, when you need to add a new module to your project. Second, when you want to build a new version of your website or application. And third, when you want to add and test new functionality. In all 3 cases, the answer is the same. Create a branch. The golden rule here is never experiment directly on your main project. Always branch off, do your work, and only bring it back when you're confident it works. Now, let's watch how the instructor actually sets this up from scratch. He creates a brand new project, a school website, and opens it in VS Code. The first thing he does is run git status in the terminal. And what does Git say? It says there's no Git repository here. No .git folder exists, so Git has no idea what to do. This is the error you'll see whenever you try to use Git in a folder that hasn't been initialized yet. The fix is simple. You run git init. That one command creates the hidden .git folder, and now Git can start tracking your project. After running git init, the instructor shows us something interesting, the .git folder that gets created. Now, this folder is hidden by default, and that's intentional. It stores all of Git's internal tracking data. The instructor makes a point of saying he only enabled the visibility of hidden files to show us what's happening behind the scenes. In your normal day-to-day work, you don't need to see this folder, and you definitely shouldn't be editing anything inside it. Just know it's there, doing its job quietly.
Once you initialize a Git repository, you're automatically placed on the master branch, or sometimes it's called main, depending on your Git version and settings. The instructor points out that the branch name itself doesn't matter. You can have a branch called production, stable, or anything else. The name is just a label. What matters is that this is your primary branch, the one where your stable, working code lives. You can see which branch you're on right in the VS Code status bar at the bottom left corner.
The instructor then starts building the school website on the master branch. He creates an index.html file, sets up a standard HTML boilerplate, and builds a navigation bar with 3 links: home, services, and contact. Now, he makes a really important observation here. In this demo, the menu took maybe 10 seconds to build, but in real life, a navigation menu with responsive design, styling, search functionality, that could take you 2 full days. So the point is, once you finish a complete unit of work like this, that's when you commit. Not before, not in the middle, when one atomic unit of work is done. This is a principle the instructor emphasizes strongly, the idea of an atomic commit. An atomic unit means one complete, self-contained piece of work. You finish building the navigation menu, everything works, then you commit. You don't commit halfway through. You don't commit a broken feature. The commit should represent a meaningful checkpoint in your project, something you could come back to and say, yes, this version was working correctly. Keep this rule in mind every time you sit down to code. Now, here's where it gets interesting. The instructor shows us how to actually create a new branch. You use the command git branch, followed by the name you want to give the branch. In his example, he creates a branch called Climax. This is for a new feature or section he wants to add. When you run git branch on its own, it lists all your branches and puts an asterisk next to the one you're currently on. Notice something important. Creating a branch does not automatically switch you to it. You're still on master after running git branch climax. You have to explicitly switch. To move between branches, you use git switch, followed by the branch name. The instructor demonstrates switching to the climax branch and then back to master. Here's the really mind-blowing part that the instructor highlights. When you switch branches, the actual files in your project folder change. If you made changes on the Climax branch and then switch to master, those changes disappear from your view. They're not gone, they're safely stored on the Climax branch, but your working directory reflects whichever branch you're currently on. This is Git's magic at work. The instructor makes this concrete with a live demonstration. He adds some content, a new section called Climax, while on the Climax branch. Then he switches back to master. And just like that, the content is gone from view. Switch back to the Climax branch, and it reappears. This is branch isolation working perfectly. Each branch has its own version of the files. You can have 2 completely different states of your project existing simultaneously, and you just switch between them using git switch. This is incredibly powerful for team collaboration and feature development. Once you're happy with the work on your feature branch, you bring it back into master using git merge. The instructor explains a specific type of merge called a fast-forward merge. This happens when the master branch hasn't had any new commits since you branched off. In that case, Git doesn't need to do any complex combining. It simply moves the master branch pointer forward to include all the commits from your feature branch. It's clean, it's simple, and there are no conflicts. The instructor notes this is the easy case and hints that there's a twist coming when things get more complicated. Continuing from where we left off, let's talk about the commit process, and more specifically, when you should commit. The instructor makes a really important point here. You should only commit when one complete atomic unit of work is done, not halfway through, not when you've written half a feature, when it is fully done. Think of it like this. If you're building a navigation menu and it takes you 2 full days because of all the responsive design work, you don't commit halfway through that menu. You commit once the entire menu is finished. This is what's called an atomic commit. One task fully completed, then committed. Here's how the instructor demonstrates the commit process in practice. He has an index.html file in his working directory. First, he runs git add index.html. This moves the file from the working directory into the staging area, which he calls the waiting room. Then, once it's staged, he runs git commit-m, followed by a message in quotes, add navgar on homepage. That's the commit message describing what was done. After this command, the file moves from the staging area into the repository. It's been committed. The instructor uses the metaphor of an airplane. The file has now boarded the plane and taken off. After committing the navigation bar, the instructor adds a new section to the page, a hero section. He creates a section element, adds a div inside it, puts an h1 heading that says hero section, and adds some placeholder lorem ipsum text. This is a separate piece of work from the nav bar, so it gets its own separate commit.
He runs git add index.html again to stage the changes, then git commit -m with the message add hero section on home page. Notice the pattern. Each distinct feature or unit of work gets its own descriptive commit message. This keeps your project history clean and easy to understand. Up until this point, the instructor has been working solo on the project, but now he introduces a real-world scenario. Imagine you're a developer working for a client. They hired you to build a school website for 50,000 rupees, and you agreed to finish it in 1 month. Then suddenly, the client calls and says they need it done in 3 days. That's an emergency. To meet that deadline, you can't work alone anymore. You need a team. And when a team works together on the same codebase, that's exactly where Git branching becomes essential. Multiple people can work on different features simultaneously using separate branches. Now let's get into branches. The instructor explains that when you create a new branch, Git takes an exact copy of whatever is currently in your master branch and puts it into the new branch, so both branches start with identical code. To see your existing branches, you run git branch, and it shows you how many branches you have. To create a new branch, you run git branch followed by the branch name. The instructor names his new branch about page, using a hyphen instead of a space, because branch names follow identifier rules just like variable names, so no spaces are allowed. After running this command, the new branch is created, but you're still on the master branch. Once you've created a new branch, you need to actually switch to it to start working there. The instructor shows 2 ways to do this. The old way is git checkout followed by the branch name. This still works, but it's considered outdated. The new recommended way is git switch followed by the branch name. So to go to the About Page branch, you'd run git switch About Page. When you run git branch after switching, you'll see both branches listed, and the one with an asterisk next to it is the branch you're currently on. The instructor emphasizes, always use git switch. It's the latest command and the one you should get used to. Now that the instructor is on the About Page branch, he creates a new file called about.html. He copies the structure from index.html, because the navigation menu should be the same, and then modifies the main section. Inside the main section, he adds a new section element, a div, an h1 heading that says About Us, and some lorem ipsum placeholder text. After saving the file, he stages it with git add about.html and commits it with the message add about page. This commit only exists on the About Page branch. The master branch doesn't know about this file yet. This is the most important concept to understand about branches: isolation. When the instructor switches back to the master branch using git switch master, the about.html file completely disappears from the file explorer. It's not deleted, it's just on the other branch. The master branch only has index.html, exactly as it was before. Then when he switches back to the About Page branch, about.html reappears. This is the power of branching. Your original working code stays untouched on the master branch. You can experiment, build new features, even break things on a future branch, and your original code is completely safe. If something goes wrong, you just delete the feature branch and start over. Let's visualize what the branch structure looks like at this point. On the master branch, we have 2 commits, one for adding the navbar and one for adding the hero section. Then, from that second commit, a new branch called About Page was created. On the About Page branch, there's one additional commit, adding the About Page file. The master branch hasn't changed at all since the branch was created. This is the typical workflow. Master holds your stable, production-ready code, and feature branches hold work in progress. You can have as many branches as you need, one per feature, one per team member, whatever makes sense for your project. The instructor also mentions that you can create a branch and switch to it in a single command. Instead of running git branch about page and then git switch about page separately, you can combine them into one command, git switch -c about page. The -c flag tells Git to create the branch and immediately switch to it. This is a handy shortcut you'll use often. And remember, always create your new branch from the correct starting point. If you're adding a new feature, you typically want to branch off from master, so your feature branch starts with the latest stable code. Once you've finished working on a feature branch and everything is tested and working correctly, you need to bring that work back into the master branch. This is called merging. The process is straightforward. First, switch back to the master branch with git switch master, then run git merge, followed by the branch name, in this case, git merge about page. The instructor points out that in this particular scenario, because the master branch hasn't had any new commits since the About Page branch was created, Git performs what's called a fast-forward merge. This is the simplest type of merge. Git just moves the master branch pointer forward to include all the commits from the feature branch. No conflicts, no complications. Here's a critical real-world rule the instructor emphasizes, and this is something you absolutely need to remember when you start working at a company. In a professional environment, you as an individual developer will almost never be allowed to merge your own branch directly into master. The master branch is protected. Only senior developers, team leads, or designated reviewers have the authority to merge code into master. Your job is to work on your feature branch, push it, and then create what's called a pull request, asking for your code to be reviewed and merged. We'll cover that process when we get to GitHub, but keep this rule in mind. Never merge into master on your own in a team setting.
Now, the instructor introduces a twist, a scenario that leads to what's called a merge conflict. So far, we've had one feature branch called About Page, but now imagine another developer joins the project and creates their own branch called Comedy. The instructor demonstrates this by running git switch -c comedy, using the -c flag to create and switch to the new branch in one step. Now we have two separate branches, both forked from the same point on master. The question is, what happens when both branches have made changes to the same file? That's where merge conflicts come in, and that's exactly what we're going to explore next. So once you've tested your feature branch and everything looks good, the next step is merging. Merging is simply the process of taking all the work you did on a separate branch and bringing it back into the main branch, the master branch. Think of it like finishing a chapter of a book on a separate notepad, then copying it into the final manuscript.
Here's a very important real-world rule that every developer needs to understand. In a company, you do not merge your own code into the master branch yourself. You create your feature branch, do your work, and then send what's called a pull request. Basically a request saying, hey, my work is done, please review and merge it. A separate person, a team lead or senior developer, reviews your code, tests it, and only then merges it into master. This is a critical workflow rule you must remember. The master branch, sometimes called main or stable, is your production branch. This is the live version of your website or application. This is what your clients actually see and use. Feature branches are where individual developers do their work in isolation. One developer might be building the login system, another is building the registration system. Neither of them has the other's code yet. But eventually, all of that work gets merged into master, and that's how the final product comes together, piece by piece, branch by branch.
The command itself is straightforward. First, you switch to the master branch because you want to merge into master. Then you run git merge followed by the name of your feature branch. In this example, the branch is called About Page, so you type git merge About Page. And just like that, all the commits and changes from the About Page branch are brought into master. Notice that About Page here is the branch name, not a file name. Don't confuse the two. When the merge goes smoothly without any conflicts, it's called a fast-forward merge. This is the simplest case. What happens is, since no one else made changes to master while you were working on your feature branch, Git simply moves the master pointer forward to include your commits. No errors, no conflicts, no drama. It's as if you just pasted your work directly into master. The instructor specifically names this fast-forward merge, and it's an important term to remember. However, this clean scenario doesn't always happen in real team environments. Here's another important rule. A branch is meant to be used once. You create it, do your assigned work, merge it, and then delete it. Once the About Page branch has been merged into master, your job on that branch is done. You don't keep using it for future work. If you need to add something else later, you create a brand new branch. The command to delete a branch is git branch -d, followed by the branch name. And critically, you must be on the master branch when you do this. You cannot delete a branch while you're currently inside it. Why bother deleting branches? Imagine you work on a project for a year. You create a branch for every feature, About Page, Services Page, Contact Page, Login Fix, Image Fix, Footer Update, and you never delete any of them. You'd end up with hundreds of branches and have no idea which ones are active, which are done, and which are abandoned. Deleting a merged branch is just good hygiene. Once the work is merged and done, the branch has served its purpose. Delete it, keep your repository clean. There's a handy shortcut worth knowing. Instead of first creating a branch with git branch and then switching to it with git switch, you can do both in a single command, git switch -c followed by the branch name. The -c flag stands for create. So git switch -c About Page creates the About Page branch and immediately switches you into it in one step. After you press enter, you're already inside the new branch and ready to start working. Let's walk through a complete practical example. The client says the About Page is missing an image. Here's the full workflow. First, create and switch to a new branch, git switch -c About Page. Then open about.html and add an image tag. You can grab an image URL from a site like Lauren Pixum. Stage the file with git add, then commit with a message like add image on about page. Now switch back to master with git switch master. Notice the image is not there in master yet. Then run git merge about page, and now the image appears in master too. Finally, clean up by deleting the branch with git branch-d about page. That's the complete cycle.
Now let's talk about a term you'll encounter constantly in Git: head. Head is simply a pointer. It tells Git where you currently are. It points to the latest commit on your currently active branch. So if you're on master, head points to master's latest commit. When you see head mentioned in conflict markers or log output, it means this is what's currently in your active branch. This becomes especially important when you're dealing with merge conflicts, which we're about to look at. To understand merge conflicts, the instructor uses a creative story example with 3 people working on a text file. The master branch has the first line, Johnny, Johnny, yes, Papa. One developer creates a climax branch and adds a second line, eating sugar, no, Papa. Another developer creates a comedy branch and adds a different second line, telling lies, no, Papa. Both branches have modified the same line, line 2, with different content. When you try to merge both into master, Git doesn't know which version of line 2 to keep. That's a merge conflict. The second developer creates a comedy branch using git switch-c comedy. Inside this branch, they edit the story file and add their line, telling lies, no, Papa. They stage and commit this with the message add comedy. Now there are 3 branches in the repository, master, climax, and comedy, and each has a different version of the story file. This is the classic multi-developer scenario, everyone working independently on the same project, each in their own branch. Back on master, the first merge is easy. Run git switch master to get back to the main branch, then git merge climax. Since master hadn't changed since the climax branch was created, this is a clean fast-forward merge. Master now contains both lines, Johnny, Johnny, yes, Papa, and eating sugar, no, Papa. No errors, no conflict. But now watch what happens when we try to merge the comedy branch. When you run git merge comedy, Git hits a conflict and stops. It opens the file and shows you the conflict markers. The section between less than head and equal signs is what your current branch, master, already has. Eating sugar, no, Papa. The section between equal signs and less than comedy is what the comedy branch is trying to bring in. Telling lies, no, Papa. Git is essentially asking you, which one do you want to keep, or do you want both? You have to make that decision manually. To resolve the conflict, you manually edit the file. You have 3 options. You can accept the current change, keeping only what master has, which is eating sugar, no, Papa. You can accept the incoming change, keeping only what the comedy branch has, telling lies, no, Papa. Or you can accept both changes, which is what makes sense here for the story. You delete all the conflict markers, the less than signs, the equal signs, the greater than signs, and keep both lines. The final file now has all 3 lines of the story together. That's conflict resolution. Once you've resolved the conflict and the file looks exactly the way you want it, you stage everything with git add dot. The dot means all files. Then commit with a meaningful message like added climax and comedy. After that, delete both the climax and comedy branches since their work is now merged and done. Run git branch.d climax and git branch.d comedy. Now if you run git branch, you'll see only master remains, clean, complete, and containing everyone's contributions. Let's bring everything together. The master branch is your production code. Treat it with respect and never push directly to it in a professional setting. For every new feature or fix, create a dedicated branch. Use git switch-c to create and switch in one command. When your work is done and tested, merge it back into master. If only you change things, you get a clean, fast-forward merge. If multiple people change the same lines, you get a conflict, and you resolve it manually by choosing which changes to keep. Head is just Git's way of saying where you are right now. And finally, once a branch is merged, delete it. Keep your repository clean. One branch, one task, one merge. That's the professional Git workflow.